So today I will talk about velocity and acceleration in Cartesian and polar coordinates. So I will talk about velocity and acceleration in Cartesian and polar coordinates in 2D plane, right? So first of all, let me define the velocity. Velocity is basically change in displacement per unit time. Suppose we are having a plane, say it is xy plane, and say at any time object is supposed to be here, and after some time it reaches at this point. It reaches at this point, then this is known as the displacement, and it is r2. This is at time t1 and this is at time t2. Then velocity is defined as, rather than call it as dr, let me call it as a delta r, right? This is r2, this is r1. So that means this velocity is basically change in displacement, and the displacement is basically delta r, means r2 minus r1, and the time for r2 the time is t2, and for this the time is t1, so we can call it as the delta r over delta t. So this is the average velocity of the particle. But when this delta t approaches to 0, then this v will become instantaneous. We can write down it as limit delta t approaches to 0 delta r by delta t, and it can be written as dr over dt. So in such a case this delta r is replaced by dr vector, right? So let me first of all talk about that is what is dr in terms of Cartesian coordinates. So this is what dr. This dr vector, it can be written as dr is equal to, it is dx I cap as we have discussed it earlier, and dz k cap. And now how this velocity can be written as, it is the dr upon dt. So this simply is the dx upon dt I cap, and it is dy over dt j cap plus dz over dt k cap, right? Then how this can be written? This is equal to, in short notation this can be written as r dot is equal to, it is x dot dot means it is, when I am putting dot over this, it means I am talking about the time derivative. So this notation we will use in the later on, and it is y dot and j cap and plus z dot k cap. So this dot is basically is a short notation to represent the time derivative. So this we have to keep in mind. So now this velocity, so it is basically v vector and this magnitude of B vector can be written as x dot square plus y dot square plus z dot square. So right, then let me talk about acceleration. So what is acceleration? Acceleration is basically, it's represented as in the similar fashion, change in velocity with time. Means it is related to change in velocity with time, or rate of change of velocity. In other words, I can also call it as rate of change of velocity. So I am not talking about it detail because you have studied all these things in the lower classes. So that means I can write down acceleration simply, it's a dv over dt. So what it is will be d upon dt of, because velocity can be written as x dot I cap, y dot j cap and z dot k cap. So I can write down it as like this. So it is a dx dot over dt I cap, because I, j and k, these directions are not changing, these are the fixed directions. Similarly, I can write down it as a dy over dt j cap plus dz over dt z dot, it's a k cap. Or because I am taking a second order derivative of position, it means that because as I know that x dot is the dx over dt and y dot is basically dy over dt and z dot means dz over dt. So I can also, if I put these values here, then this can be written as d square x over dt square I cap plus d square y over dt square j cap plus d square z over dt square k cap. It can also be written like this, and it is a second order derivative. So for the second order derivative, we simply put the x double dot I cap, and for this I have to put it like this, y double dot j cap and z double dot k cap, right? So and the magnitude of it can also be written as like this. So what is magnitude? The magnitude of it will be a is equal to x double dot square plus y double dot square plus z double dot square, and taking wholes under the root. So this is a way that how acceleration can be calculated, means acceleration in terms of vector form, and its magnitude can be written like this. Now let me talk about that how velocity in the plane polar coordinates can be written. And here I have talked about it for the 3 dimension, and for 2 dimension how velocity and acceleration written as. For 2D, velocity can be written as x dot I cap y dot j cap, and magnitude of velocity can be written as x dot square plus y dot square whole under the root. And similarly, acceleration can be written as like this. Acceleration is equal to x double dot I cap y double dot j cap, and magnitude of it can be written as x double dot square y double dot square under the root. And here it can be or sometimes it is written as dx over dt I cap plus dy over dt j cap, and here this can also be written as d square x over I cap, then dt square is here, plus d square y over dt square j cap, right? So this is way how velocity and acceleration can be written in the 2-dimensional Cartesian coordinate system. Now let me talk about velocity in plane polar coordinates. Let me talk about velocity in plane polar coordinates. Velocity in plane polar coordinates. So velocity, how it can be written as, so the velocity is basically dr vector over dt. And what is r vector? R vector is written as like this. R vector means it is this r vector means it is the r multiplied by its unit vector. So it is r multiplied by its unit vector. So what is happening in plane polar coordinates? Our coordinate system is like this. So this is here, this is the unit vector is along this direction, and when point approaches at this point, say it is here, so here the unit vector will become this. So that means unit vectors are changing. When object is supposed to move over a plane, then its plane polar unit vectors changes their direction. Means plane polar unit vectors changes. And say angle is this, so the I cap here, the theta cap is along this direction. When object is here, then it is like this, so its unit vector is changing like this. It is theta cap is going like this. So r cap and the theta cap both are changing with time. So what I am concluding from here, that r cap and theta cap changes with time. But on the other hand, I cap and j cap, because this is I cap direction and this is the j cap direction, these are not changing with time. Not changing with time, right? So let me take its derivative. So what do I do? So that means the derivative of first quantity and second quantity will remain as it is, plus first quantity as it is, and the derivative of second quantity, because I will apply a chain rule here. So what is it? This is r dot and r cap as it is, plus r as it is, and what is dr by dt? So let me write down it as the d over dt. So what is it? This is r cap is basically cos theta I cap plus sin theta j cap. So how it can be written as, this is r dot r cap plus r, and what is the derivative of cos is minus sin theta, and I cap is not changing, so it will remain as it is, and the derivative of sin is the cos theta, and it is j cap, it will remain here, right? So it is r dot r cap plus r into, what is it? It is theta it's another thing. Yeah, theta is also changing, so I have mistaken somewhere here. So it is r dot r cap plus r into, the derivative of cos will be minus sin theta, and again derivative of theta, so it is d theta over dt. I cap will remain as it is, plus cos theta d theta over dt, and j cap will remain as it is. So how it can be written as r dot r cap plus r minus sin theta, theta dot I cap plus cos of theta, theta dot j cap. So theta dot can be taken outside. So it is r dot r cap plus r theta dot minus sin theta, I cap plus cos theta j cap. So what it will be? Yeah, so it is r dot r cap plus r theta dot, and it is basically theta cap. So that means velocity can be written as r dot r cap plus r theta dot theta cap. So it is r component, vr component, and this is theta component, so we call it like this. So what is Br is basically r dot, and V theta is equal to r theta dot. These are the few things which we have to remember. So let me talk about that. What is acceleration? So yeah, let me talk about now the acceleration in plane polar coordinates. So as we know that acceleration is basically dv over dt, and what it will be? d over dt r dot r cap plus r theta dot theta cap. So what it will be? So it is let me take first of all its derivative. So it is dr dot over dt r cap plus r dot dr cap over dt. This is its derivative with respect to time. Now I will talk about this part. So what it will be? This is d r over dt means its derivative, and rest of the term will remain as it is. So it is theta dot theta cap plus r d theta dot over dt, and theta cap will remain as it is, and then I will write down it as r theta dot d theta cap over dt. Right, so these are the things which we are getting here, and this is r double dot. So this is r double dot r cap plus r dot. It is also r dot. This is also r dot. Yeah, no, this is not r double dot. Yeah, this is r dot dr cap over dt plus r dot theta cap plus r theta double dot theta cap plus r theta dot d theta cap over dt. Now my objective is to find out the value of this one. We have to find out that what is this and what is this, right? So let us try to find out this. So dr over dt. So dr cap over dt. So how? It can be written as d upon dt, and it is cos of theta I cap and sin theta j cap. And let me take its derivative. So its derivative is minus sin theta d theta over dt, and I cap as it is plus cos theta its derivative, and again derivative of d theta, so it is j cap. So what it will be? It is theta dot, and it is also theta dot, so it can be taken outside. So if it can be taken outside, so it will become theta dot. So inside it is sin theta I cap plus cos of theta j cap. So what it will be? It means it is theta dot and this is basically theta cap. So let me put it here, because I have to use it here. So dr cap over dt is equal to theta dot theta cap. Similarly, I will try to find out d theta over dt, d theta cap over dt. So what it will be? So d theta cap over dt, it is d over dt minus sine theta I cap plus cos of theta j cap is at like this. So it is derivative is minus cos theta theta cap theta dot I cap plus, so it is not plus but the derivative cos will be minus sine theta, again derivative of theta, it is theta dot and it is j cap. So let me take theta dot outside, so minus theta dot when it is taken outside, so inside it is cos of theta plus sine of theta. So it can be written as minus theta dot r cap. So let me write it down here. So that means this d theta cap over dt is equal to minus theta dot r cap. So let me put these values here. So it can be written as r double dot r cap plus r dot and theta dot theta cap from here plus r dot theta cap plus r theta double dot theta cap plus r theta dot and minus theta dot r cap. So let me club these two values. So what should I do? It is and r cap is here and r cap is also here and theta cap is sitting with these three terms. So let us club all these terms. So it is r double dot minus r theta dot square, because both will become theta dot square with negative sign, and it is r cap plus 2r dot theta dot both put together and plus r theta double dot and theta cap is taken outside because these three terms containing theta cap. So therefore this a can be written as ar plus a theta vector, and here where what is ar vector is basically r double dot minus r theta dot square into r cap, or simply I can write down it as radial component, that is ar is simply r dot minus r theta dot square, and similarly a theta can be written as 2r dot theta dot plus r theta double dot theta cap, or I can write down as a theta is equal to 2r dot theta dot plus r theta double dot. It is known as transverse component of acceleration. Transverse component of acceleration, right? So this is a way that how these acceleration and velocity can be written in terms of plane polar coordinates. So that's all for this lecture.